so Unit 6 review, number 17, hopefully to the end on this video. So in question 17, and actually to the end, all of these are about solving, and so this is where everything that you've learned in this unit really comes together. You need to use all your properties, and you need to use some things from previous units, like some quadratics show up and such. Okay, so in problem A, I want to make use of the fact that the subtraction with logs is really division. If I rewrite it using my log properties. And then I want to use what I call the justice in the universe question property, which is if I have an equal sign and these two things are actually the same, equals means equal, and so in order for these two sides to be equal, the rest of it would have to match. And 3 is the same as 3 over 1, then I'm going to cross multiply to finish that out, okay? I'll show you that on the next slide in just a second. In B, the addition means that I could rewrite this as a multiplication problem. So I would multiply x minus 5 times x minus 2, and that equals 1. If I use another thing that I know about logs, I can rewrite them in exponential form. So if I just have a log on one side of the equation, that's different than like the previous question. In the previous question, I had a log on both sides with an equals in between, and those logs were the same base, so I could just kind of like quote unquote cancel them out. Here, I only have a log on one side. If that's the case, I want to use exponential form, okay, and say I have 4 to the first, and that has to equal this. And you might recognize the form of this equation from old times, right? This is just a quadratic. I'm going to multiply that out and get x squared minus 5x minus 2x is minus 7x plus 10 equals 4. I need to move this 4 over, so I have 0, my powerful hero, in order to factor and solve. So here are the rest of those solutions. The one I just was talking about, here I am getting 0, here I am factoring, here I am solving, and we should check and make sure that we have solutions that actually check, because remember, you can only take a log of a positive amount. And so if I have something, like if I have a solution that came out of the quadratic that is negative, leads to me taking a log of a negative, that's not okay. So that becomes a solution that does not check. We call that an extraneous solution. The other part I left off on the previous slide right here. We would cross multiply. So notice here that the 3 gets distributed through. So I shouldn't have 3x minus 1. If you have that, you forgot to distribute. So 3x minus 3, and then just solve that beautifully. Okay, the next couple questions, very similar to what we saw on the last page. So this subtraction is going to be a division statement. And because I just have a log on one side, I'm going to use exponentiation, switch it to exponential form. 3 to the 4th is 81, so I'm going to say this is 81 over 1. And then I would cross multiply to solve. I'll show you that on the next slide. Okay, over here what I would do is try to have the logs get together with each other, because right now they're on different sides. So I have the base 2 log of x, and then I'm going to subtract this whole chunk over to this side and leave my plain 2 right there. This 1/2 could be rewritten as an exponent because of log properties, and subtraction means to divide because of log properties. Okay, now I just have a log on one side of the equation, so I'm going to switch this to exponential form. 2 to the 2nd equals that whole glob. So 2 to the 2nd is 4, and that equals this. I'm going to think of the 4 as 4 over 1. And then I'm going to cross multiply. And I'd have 4 radical x minus 3 equals x. And this is a problem type we saw earlier in the year as well. So solving radical equations, that's something that we've done. To get rid of a square root, I want to square both sides. So I'd have 16, 4 times 4 is 16. A square root and a square are inverse operations. And I'd have this. Okay, so I'm going to finish out both these questions by showing you the next slide. In the question we were just talking about, I left off right here. So I would distribute the 16 and get everything on one side of the equation so I can have 0 to help me with my factoring and my solving. I have to have 0 in my hero. Then we factor and then we solve. Okay, on this one, I left off, I think, right here. And so cross multiply and then isolate your x, solve for x. All right, this question. Again, we're going to make use of log properties. So I have a subtraction sign here, which means I divide the two expressions or quantities. And this is a problem where I have equal sign and these are the same. So the equation, the equals, tells me that these have to be equivalent. If the parts that I underlined in red are the same, the parts that I underlined in blue have to also be the same. Otherwise, I wouldn't have an equal sign. Okay, and now we've seen this idea on a couple of the other questions. This is a cross multiplication issue. So I'd have opposite of x equals, and remember to distribute, 30 minus 10x. If you'd like to write the 10 and then 3 minus x first and then show the distributing, that's fine. That's the same. And then we would put the x's all onto the same side and divide by 9. And you can reduce that if you wish, or write it as a decimal if that makes you happier. All right. This question is similar in content to what we just did. Now, honestly, since it is multiple choice, you could go through these and just substitute in and see what you think. Like, for instance, I am pretty sure that we are not going to pick A, because if I put -1 in there, I'm going to get log of a negative. So that can't be. So like right off the top, I know that. And so I could kind of back solve, but it's important for me that you also know how to front solve, question mark. Is that the right way to say it? Forward solve. Okay, so adding with logs, we're going to multiply. There's just a log on one side of the equation, so I'm going to rewrite that by using exponential form. 4 to the 1/2 is the same as saying square root of 4. That's 2. And then multiply this out. Move the 2 over. And you have the quadratic 2x squared minus x minus 3, which does indeed factor. So I'm going to show you that on this page. It does indeed factor. You get 2 solutions, and this is why answer choice A was there, because you do get -1 as the solution for the quadratic, but it doesn't check in the original problem. So you should just have 3 halves. All right, this problem, we are going to put the logs on the same side of the equation so we can make use of log properties. I wouldn't have to do that except for this 1 being there, right? If it just was log of something equals log of something, then I would say the somethings have to be equal. But the fact of that 1 being there is preventing me from doing that. Okay, so now I have the logs on the same side. I can make use of log properties, which says I'm going to multiply those 2 expressions together as a single log. I can exponentiate, so 5 to the first equals, I'm going to multiply that out. That's a difference of 2 squares pattern. So I've just got this guy. So I've got 9 equals x squared. So x would equal plus or minus 3. But I need to check that that works. If I put -3 into either of these, I am in a bad place, right? So it is just the 3 that works. Right? I cannot take a log of a negative amount, right? So I have an extraneous solution for the other guy. And problem 20. Which of the following which equation has a solution of 6? I honestly would just substitute it in. I'm just saying that's an awful lot of equations to solve. So you can see here that I just plugged in a 6 and I wrote out what I got each time. And when I got to D, I was super excited because even though it might not at first glance look like log of 6 plus log of 4 has to equal log of 3 plus log of 8, I know that when I am adding, That is adding with logs. That's the same as multiplying. So the left side here is log of 24, as is the right side. So that's your guy. Okay, I would just check that. Check that with your calculator, or check it with, like how I wrote it out. I didn't actually use my calculator. I just wrote it out until I found something that I knew to be true. So I hope that is clear enough for you. And thanks for persevering through this very, very long review. And I hope you guys are doing all right. Try to get outside each day and take a walk. Do something that's going to make you feel healthy and connected. Okay? We miss you. Bye.